Everyone, welcome back to the channel. Today, we're tackling a common challenge when dealing with APIs that return lots and lots of data, API pagination. Ever scrolled endlessly through pages of search results or social media feeds? Well, pagination is the technique that breaks that massive data down into smaller, more manageable chunks. It makes things faster, more efficient, and way less overwhelming for both the server and the user. So, why is pagination so important? Imagine an API that could potentially return millions of user records. If you tried to grab all of that in one go, it would be incredibly slow, consume a ton of resources, and might even crash the server or your application. Pagination solves this by delivering the data in bite-sized pieces, like pages in a book. There are several common strategies for implementing API pagination, and today we're going to explore the top 5, plus a hybrid approach. First up, we have offset-based pagination. This is probably the simplest approach. You use an offset parameter to define the starting point in the dataset and a limit parameter to specify the number of records you want to retrieve in that page. For example, a request might look like get/orders, offset equals 0 and limit equals 3. This would give you the first 3 orders, records 0, 1, and 2. To get the next page, you'd increment the offset, like get/orders, offset equals 3 and limit equals 3 to get orders 3, 4, and 5, and so on. While easy to implement, offset-based pagination can become inefficient with very large datasets, especially when you're trying to access data deep into the results, as the server still has to skip over all the preceding records. Next, we have cursor-based pagination. Instead of an offset, this method uses a cursor, which is a unique identifier to mark your position in the dataset. The server provides this cursor in the response for the current page, and you use it in your next request to fetch the subsequent set of records. A request might look like get/orders, cursor equals XXX, where XXX is the cursor from the previous response. This approach is generally more performant for large datasets because the server doesn't need to count or skip records based on an offset. However, the cursor itself needs to be carefully managed by the API. Then there's page-based pagination. This is similar to offset-based, but instead of directly specifying the starting record, you specify the page number you want and the size of each page. For example, get/orders, page equals 2 and size equals 3 would request the second page of results, with each page containing 3 orders, so, orders 3, 4, and 5, assuming the first page is page equals 1. This is user-friendly as it aligns with the concept of pages we're familiar with, but like offset-based, it can still have performance issues with very large datasets and deep pagination. Another efficient method is keyset-based pagination. This technique uses a key to filter the dataset, often the primary key or another index column, along with a limit. For example, if your orders have a sequential ID, you might request the next set of orders after a specific ID. A request could look like get/orders, after _ID equals 102 and limit equals 3. This would fetch the next 3 orders with an ID greater than 102. This method is generally very performant, especially with proper indexing, as the database can directly jump to the relevant records. You often see this used with timestamps or other ordered keys. We also have time-based pagination. As the name suggests, this uses a timestamp or date to paginate through records. You might specify a start time and an end time to retrieve records within that range. For example, get/orders, start_time equals XXX and end_time equals YYY. This is particularly useful for APIs dealing with time series data or logs. Finally, we have hybrid pagination. This approach combines multiple pagination techniques to leverage their strengths. For example, you might use a cursor for general navigation but also allow filtering by date ranges. A request could look something like get/orders, cursor equals ABC and start_time equals XXX and end_time equals YYY. This allows for more flexible and optimized data retrieval based on different use cases. Choosing the right pagination strategy depends on factors like the size of your dataset, the frequency of access, the sorting requirements, and the performance goals of your API. Each method has its own trade-offs in terms of implementation complexity and efficiency. Thanks for watching.